the area and perimeter of the shape below. Show your steps. So we have a complex figure here. You can see that we have a triangle that is attached to a rectangle. So this is going to be, there are going to be quite a few steps here, but I promise you that you have all of the knowledge you need to solve this. It's just a matter of persevering to get through it. So let's go ahead and get started. Perimeter, of course, means the area around the outside edges of this figure. So I know that I have 3 measurements now. This is 10 meters. This is 21 and 25 meters. This is 7 and 6/10 meters. So based on the information that I'm given, is there anything else I can fill in? Remember, it's just the outside of the figure. Well, I know that this length here must also be 21 and 25 meters, right? Because it's the same length as this side. So I can write that in. Now, I need to figure out the length of this side. But oh my goodness, how am I going to do that? There's no other diagonal. This is the only diagonal, and I have no information on this, right? Wrong. Actually, we can figure out that diagonal using the Pythagorean theorem. So I'm going to go ahead and trace over this line here. So this line is the same as the other on the opposite end of the rectangle, and it is 7.6 meters. Hey, check it out. It's a right triangle, and we've been given the 2 legs here. So what we can do is just go ahead and plug into that Pythagorean theorem formula. So we have that a squared plus b squared equals c squared. Don't like that equals sign. It's a little bit better. And they've given us both legs. So we need to figure out the hypotenuse. And the hypotenuse is always c, remember? So we'll plug in, we'll do 10 squared plus 7.6 squared. That equals c squared. So 10 squared, we should know 10 times 10 is 100. And then plus, 7.6 squared. Yeah, I don't know that off the top of my head. So I'm going to put it into my calculator. 7.6 squared is 57.76. So 100 plus 57.76 equals c squared. And c squared equals 157.76. All right, so if 157.76 equals c squared, we know that's not the length of our diagonal, right? That's our diagonal squared. So how do we undo the squaring? Well, we take the square root from each side. That gets c by itself. And then that is going to give us, let me see, I'll put it into my calculator here, 157.76. It's going to give me approximately, we'll round to the nearest tenth, so we'll say 12.6. Since I'm rounding, I need a squiggly sign, so approximately 12.6. I do need to erase this so I have room to do the other work, but you do want to make sure that you copy everything that I'm writing down. So yes, there are multiple steps, but they're all really important and valid parts of this problem. So if you need to pause, go ahead. Again, that was 12.6 meters approximately. So I'm going to erase so I have some room to do the next step. And again, that's not our perimeter, that's not our area, that is simply the length of this diagonal. So I told you we were going to have some steps here. I'm going to go ahead and erase this since I am determining the perimeter. So now I've got all of my side lengths, my outer side lengths, so I can add them together. So for the perimeter, we know we add all of the sides, so we're going to add 10. I'm going to start right here. 10 plus 21.25 plus 7.6 plus 21.25 plus 12.6. All right, I need to put that into my calculator, so give me just a second. 10 plus 21.25 plus 7.6 plus 21.25 plus 12.6 is going to be approximately 72.7 meters. All right, and that is our perimeter. And it's perimeter, we're just dealing with the outside edges. So that's, we don't need squared or anything, just 72.7 meters. Area is next. I'm sorry if there's crinkling noises in the video. My cat, Kringle, is crawling in and out of a crinkly bag, so I do apologize for any crinkle noises. All right, that was our that was our perimeter. Now we need to find the area. So let's go ahead and take a look at our figure here. So we have, if we look at our complex figure here, we have a rectangle and we have a triangle. Yes? Yes. Okay. So we've got our two different shapes and we know how to find the area of a rectangle and a triangle. So all we have to do is find the area of that rectangle, find the area of the triangle, and then add them together. So I'm going to say, okay, my triangle area, I'm going to do my work for that here, and then my rectangle area. All right, so let's start with the triangle area. So the formula for the area of a triangle is 1/2 of the base times the height. So our base here is 10. So we'll just go ahead and plug right into our formula. So A equals 1/2 times 10 times the height. And remember, our height of the triangle shares the same length as the height of the rectangle, which is 7.6. So now all we have to do is multiply. So I'm going to put that into my calculator. 1/2 parenthesis 10 and parenthesis 7.6 and parenthesis. So when you do that, you should get, it should give us an even 38. It's 38 meters, and because it's area, it is squared. Now, this is going to be the easy part. So the area of a rectangle is just length times width. And both of those are given to us. Length, width, just plug it in. So that's going to be 21.25 times not 7.5, it's 7.6. And we'll put that into the calculator. 21.25 times 7.6. That's going to give us an area of 161.5 meters squared for the rectangle. So we're done, right? Yay. No, not quite yet. So we have one final step here. We need to take the area for the triangle and the area for the rectangle, and we need to add them together, right? So we're just going to do that 38 plus 161.5. And that is going to give us our total area. So 38 plus 161.5 gives us 199.5, and that's going to be meters squared because area is square, yeah. All right, and that is all for 1014.